What is signal conditioning? Signal conditioning is the manipulation of a signal in a way that prepares it for the next stage of processing. It is one of the most important components of a data acquisition system because without optimizing real-world signals for the digitizer in use, you cannot rely on the accuracy of the measurement. In a nutshell, signal conditioning takes a signal and makes it easier for your DAC device to measure. Types of signal conditioning. Here are some examples of common signal conditioning types, their functionalities, and examples of when you may use them. Amplifiers increase the input signal amplitude. For low voltage output signals, an amplifier can increase the resolution of your measurement. Attenuation decreases the input signal amplitude. If an output voltage is more than 10 volts, this can be used to decrease the output to fall into the range of a DAC device. Filtering rejects unwanted noise within a certain frequency range. It can be useful to remove frequency ranges or bands from vibration measurements. Excitation is required for many types of transducers and can refer to either voltage excitation or current excitation. Any sensor which changes its resistance based on the phenomenon being measured will need to be provided an excitation source. Other types of signal conditioning include linearization, bridge completion, isolation, and cold junction compensation. Types of sensors. There are many different types of sensors. Some measure voltage or current, while others measure resistance or capacitance. To achieve the best measurements, understanding the signal conditioning needs for each measurement and sensor type is paramount. For example, the most common sensors to measure temperature are thermocouples, RTDs, and thermistors. A typical signal range for a thermocouple is -80 to +80 millivolts. If you have a 16-bit digitizer with a range from -10 to +10 volts, you will only use 0.8% of the range of the ADC and will not have as much accuracy as possible. Thus, amplification could be used to improve the measurement performance.